Hey guys, I just walked into the study room and this question was written on the board and I'm just dying to know how to solve it.
Let's check it out.
Hey, let's play with Physics Girl.
Guys, stop messing around with Physics Girl. The problem's right here. So basically, Einswine's hanging on a string, and he's just centimeters away from this hot dog that's magically floating in the air. So he's relying on his collision with Physics Girl to get him far enough to reach the hot dog. Physics Girl covers about 1.17 meters.
Which is the measured distance of our table.
In a certain amount of time, which we have to measure. Then she's going to collide with Einswine. If from the time Einswine begins moving, it takes him a certain amount of time, which again we have to measure, to reach his farthest distance from his initial position, will he reach the hot dog? Given that the minimum angle between the vertical and the string for Einswine to reach the hot dog is 20 degrees, and we measured the string to be 0.53 meters long.
So if Einswine and Physics Girl are 0.1 kilograms, we first need to measure the time it takes Physics Girl to go across the table.
And once we have the time, we can calculate the speed of Physics Girl.
Let's get going. So since we measured Physics Girl's time across the table to be 1.05 seconds,
and her displacement is 1.17 meters, we can now calculate her speed.
knowing that velocity is displacement divided by time, we take Physics Girl's displacement and divide it by the time it took her to cross the table. And that gives us 1.11 meters per second. Wow, I'm really stuck now. I don't know what to do, Hayley.
I don't know what to do either.
Well, guys, since Physics Girl and Einswine have equal masses, according to the law of conservation of momentum, Physics Girl's initial velocity is going to equal Einswine's final velocity.
Oh my god, Holland!
You're a genius!
It's all because of Physics 1A03.
Now we have to measure the time it takes for Einswine to go from his equilibrium position to his max height. Are you ready, Holland?
Yep.
Here we go.
Who knew pigs could fly?
Anyways, after taking 3 trials, we calculated the average time for Einswine to reach his maximum height to be 0.21 seconds.
Okay, so now we're going to use the average velocity equation, which is displacement over time, so that we can find the displacement of Einswine from his equilibrium position to his maximum height. So we're going to do velocity times time, which will equal his displacement. And so we have 1.11 for velocity, and then
This is Einswine's time that it took for him to reach his maximum height, and then I'll do that calculation for you.
perfect,
And we get a displacement of 0.233 meters.
0.233 meters.
Almost there.
This board's getting too messy.
Now that we calculated Einswine's displacement from his equilibrium position to his maximum height, we can use the cosine law when isolating for theta to find Einswine's distance or angle that Einswine makes from his equilibrium position to his maximum height. And so Hayley is writing out the triangle that actually forms. And so as you can see here, this is Einswine's displacement, but the other 2 sides of the triangle are actually equal. And they are equal to the length of the rope, because that doesn't change, of course.
So now we've plugged it in, let's see what we get.
Will he reach the hot dog?
Einswine.
Einswine. The angle is 25.4 degrees.
He makes it!
Hooray! Thanks for watching. I'm Holland.
I'm Alessio.
I'm Hayley, and a special shout out to Physics Girl and Einswine for participating in our experiment.
We love them.
It's a perfectly elastic collision!